A portion of a student's chemistry lab manual is shown below. Use the information to write a linear equation relating the temperature, F in degrees Fahrenheit, of the compound to the time T in minutes elapsed during the lab procedure. Now, I know this sounds really scary, but we just need to break it down. First, we'll read what we get from the lab manual. Step 1, remove the compound from the freezer at -10 degrees Fahrenheit. So it's safe to say that when they removed the compound, the time was at 0. So I'm just going to make a note at that there and hope that that's clear to you guys too, that when it's first removed, time is at 0 now and the temperature is at -10 degrees Fahrenheit. Step 2, they used a heating unit to raise the temperature of the compound 5 degrees Fahrenheit every minute. And we're going to use this to find slope. Step 2 here, and I'll show you that in a second. But first, what are they asking? They're asking us to write a linear equation relating temperature, capital F, to time, T. Now, our favorite linear equation is going to be the one we use. We're going to use slope-intercept form, which is in the form y equals mx plus b. But you'll notice that in here we have f's and t's, so which one is which? Well, what this is asking us is we're relating temperature to time. In other words, we're trying to formulate an equation, a linear equation, in the slope-intercept form up here, that gives us f when we are given a value for t. That's similar up here. This linear equation up here, the slope-intercept form, we are given y when we are given a specific x. So you'll notice with the wording that I use that it becomes clear that, well, clear to me anyway, and I hope clear to you, that f is our dependent variable. It's the y. It's the one that depends on what this x value, or in our case, t value is. So I'm going to rewrite this equation here in terms of our f's and t's. So we're saying that we want to know the temperature, how much that changes. It'll still have a slope. And we want it to depend on how much time has passed. We'll still have a b, only this time it'll be an f-intercept. So first, we're going to figure out what this b is. So what our f-intercept will be. And we're going to use what we learned in what we figured out in step 1 here, what we read here, to find that out. We know that we removed the compound from the freezer at -10 degrees Fahrenheit. So we knew that f equals -10, and I'm going to drop the units just for the time being, when, and we already made a note of that, it's when it's first taken out of the freezer, so it's when t equals 0. Now I'm going to switch this back to the x and the y's just to make it kind of clear where we get b from this. Remember that our f is our y, and our t is our x. So if we were to write that into a coordinate point here, we know that x comes first, so it'd be 0, and then y comes, or our f, so -10. And you'll notice that this is the f-intercept. It's telling us that when the dependent coordinate, the t, is equal to 0, our f is equal to this. So we know that our f-intercept is -10. Next, we're going to use step 2, like I mentioned before, to find slope. Now the wording in here is the hint that gives us that this is our slope. It's going to raise the temperature, so we know that's a positive slope. It's going to, as more time goes on, the temperature is going to go up, of the compound 5 degrees Fahrenheit per minute. Now I say per minute because that gives you an idea of how this is going to be written. We know it's going to be a ratio. But to remember how that's written, I think of it in terms of miles per hour. If you're traveling 60 miles per hour, you know that you're going 60 miles per 1 hour. So what becomes before the per is 60, and after, and goes in the numerator, and after goes the denominator. So that'll make sense when we do this here. So if we say 5 degrees Fahrenheit per minute, just write that down, 5 degrees Fahrenheit per minute, per 1 minute. So we see that that's our ratio. So we know that our slope is 5. So So we're going to put what we figured out together here. We have our F-intercept, or a B. We have our M here. We're going to use this equation up here to plug it all in. So we know that we can find the temperature at any given time by multiplying that time by our slope, which is 5, times the time that we're using to figure out our temperature, plus our B, which I wrote wrong here, which is a negative 10. And that's our linear equation. It's in that slope-intercept form, except we have f's instead of y's, t's instead of x's. And this will help us if we have, let's say they want to know, a little erasing here, let's say they want to know what the temperature of the compound is after 3 minutes. Well, we plug in 3 for t, so we know that we'll figure out that the temperature is going to equal 5 times 3 for t minus 10, which gives us 15 minus 10. So we know that the temperature of our compound will be 5 degrees Fahrenheit after 3 minutes. So now here's our final answer. Here we have a linear equation relating the temperature of the compound in degrees Fahrenheit to the time in minutes. And that's our final answer.